Good morning and welcome to the November 2018 SCR Connections webinar. I'm so pleased that all of you could join me this morning, and I'm also pleased to introduce today's speaker, Dorian Janney. I think I said that right, yes. She is currently working for NASA, and she's going to tell us a little bit more about their program today. She works at the Goddard Space Flight Center in Greenbelt, Maryland. She is the Education and Outreach Specialist for Global Precipitation Measurements Mission, as well as the Globe Mission Mosquito Campaign Coordinator and lead for NASA satellite collaborations. She is a Globe Program Master Trainer and enjoys going outside with people of all ages to assist them in learning more about this fantastic planet that we live on. She was a classroom teacher for over 30 years and served as the head of the science department at a middle school focusing on aerospace technology and astronomy. Good morning, Dorian.
Good morning. What a pleasure it is to be here. Excuse me, can you hear me okay?
Yes, we can.
All right. Well, wonderful. I am coming to you today, excuse me, from the Washington, D.C. area, where I am happy I'm happy that we have had our first frost, and potentially we'll even be expecting some snow tomorrow. And I'm happy about that because I got sick and tired of being bit by mosquitoes this summer. We had a very warm and very wet summer, which made for having an abundance of mosquitoes. So that's what I'm going to be talking to you about today, telling you about some of the ways in which NASA is studying and NASA data is being used to study vector-borne and water-related disease, which of course include mosquito-transmitted diseases. And I'm going to share with you an app that can be used to help us combat the world's most dangerous animal. So let me carry on. And what I plan to do is do my introduction, and tell you the agenda, what I'm going to do right now. And then I'll, excuse me, I have terrible allergies and they're acting up right now. Then I will present on using NASA Earth-observing satellite data to predict, monitor, and respond to mosquito-borne disease, give you an introduction on that, and then I will take questions, and then I will continue and talk about the Globe Observer programs and this really cool Mosquito Habitat Mapper tool, and then again I'll stop to take questions. So my introduction, that was a wonderful introduction, and I thank you so much, Sarah. As Sarah mentioned, I do serve as the Outreach Coordinator for the Global Precipitation Measurement Mission, affectionately known as GPM, and I'm the Education Lead for the Globe Mission Mosquito Campaign. And as she said, I taught across all grade levels for over 3 decades in my previous life. I wanted to remind folks to be sure to download the Globe Observer app on a smartphone or iPad, because later, the second half of this presentation, we're going to be going through it, and it's kind of nice to have it downloaded so that you can be using it as I walk you through it. Now, the first time that you're going to use it, you need to enter an email in order to get a passcode. So that's kind of why I said go ahead and do this now, because that way you'll get your email, you'll have your passcode, you'll enter it. After you enter it the first time, you never need to enter the passcode again. This is kind of a best practice to demonstrate to you so that if you're using this information with audiences, this is something you can ask them to do ahead of time. Also something to think about. People have to have access to, or have to have internet connectivity to be able to access their email to get their passcode. So that's why you also want to make sure that they download it while they're somewhere with internet connectivity. To use the app, however, you do not need internet connectivity. You just later, when you're ready to submit your data, you do. So, all right, that's all I'll say about that for right now. One of the things that's kind of interesting to let people know when you're talking about this subject is that mosquitoes are actually the world's most dangerous animal. They're even more dangerous than humans, which I think is always kind of interesting. So it turns out that mosquitoes are responsible for more human deaths than any other kind of animal. The good news is, though, And I really like this quote from the New York Times from 2017. The best defense against the Aedes mosquitoes, and Aedes are one of the species of mosquitoes that transmit diseases. There's over 3,500 species of mosquitoes, and very, very few of these, less than 100 of these species, transmit diseases. But the Aedes is one. The Aedes mosquito is one that's an ankle biter, bites during the day, likes to get into your houses. And the best defense against the Aedes mosquito isn't big municipal gestures like spraying and other kind of protective gestures that the government might take, but it's actually your small individual actions, destroying their habitat by emptying the pools of water where they reproduce. And so that's what we're going to be focusing on later when I show you how to use that Mosquito Habitat Mapper. So people are also surprised when they hear that NASA data can be used to predict, monitor, and respond to mosquito-transmitted disease. And this makes sense when you stop to think about the fact that NASA observations, which are done via satellites. On my next slide, I'll show you some more of those satellites. Using these satellites, we are able to remotely sense data on lots of different environmental parameters all over the globe. So the satellite mission that I support, which is what's pictured in this picture here, is the Global Precipitation Measurement Mission. It's the size of a fire truck. It launched in 2014, and what it does is it flies around the Earth 24/7, and with the help of some other satellites, and you can kind of see them up in this image up at the top, it is able to give us accurate measurements to the millimeter level of how much precipitation is falling through the clouds. It does this all over the globe and updates that data every 3 hours. So precipitation is a really important environmental parameter when you're talking about mosquitoes and where mosquitoes might be. And I'll explain that more when I talk to you about the mosquito life cycle. So precipitation is huge. Sometimes it turns out that a lot of precipitation is one of those factors, one of the environmental parameters we're looking at, because a lot of precipitation means that you have a greater likelihood of having a lot of standing water, which attracts mosquitoes because that's where they want to lay their eggs. Soil moisture, that also is one that's important, again with that egg laying and having the mosquitoes around. Vegetation is important. When I talk about the life cycle, you'll hear about how it is the female mosquito who does the biting, and the reason she's biting a mammal is to be able to get a blood meal to fertilize her eggs. And after she lays her eggs, she needs some vegetation to rest on. So that's going to be an important parameter to look at. Surface temperature is one of the ones that, as I was talking about when I first got started here, that's kind of one of those key factors that we're looking at, because that determines whether or not we're going to have active mosquitoes, so mosquitoes that are out there actively biting us. Generally speaking, when the temperature is under 50 degrees Fahrenheit, mosquitoes stop being active. Now, they don't all necessarily die. They can actually go into what's called diapause and be sleeping. They can also overwinter in places where it gets below 50 degrees. They can find warmer places to overwinter, but generally speaking, though, they're no longer actively biting us. So the temperature is really important, and that's something that we measure using our satellites. And the other environmental parameter that's helpful to look at is relative humidity. So we look at all of these knowing that that surface temperature has to be above 50 degrees, and then we factor in these other variables to help us know where and when to anticipate mosquitoes. So what are NASA Earth observations? Basically, we have right now 18 satellites, plus some instruments that are on the International Space Station. And all of these satellites, with the exception of the International Space Station, are unmanned. And what they do is they're just up there orbiting Earth. Many of them are missions in which we are working with other countries, sometimes other government agencies. All of the data that we collect through these satellites is freely available to anyone, anywhere in the world. And using these different satellites and the instruments that are on board, we're able to get some really important data on these lots of different environmental parameters all over the Earth. And of course, we're able to save this data and be able to look at it, over time. The other advantage is that we're collecting this data using the same instrument, so we have that reliability and validity that is built into it. And what's really kind of fascinating is that many scientists have looked at these data and have found ways in which they could take this data and use it to better understand whatever it is that they're studying. So in this case, the studies that I've been looking at are the ways in which NASA Earth observing satellite data and other data as well have been used to help us better understand where and when we might anticipate having mosquitoes. Here is one of the most recent maps from the CDC, Center for Disease Control, showing us some of the expected potential ranges for that Aedes aegypti and also the Aedes albopictus, the two species which are most likely to, well, there's actually three species that are likely to transmit diseases. They are Culex, Aedes aegypti, and Aedes albopictus. These are the Aedes aegypti and Aedes albopictus are actually an invasive species in the United States, but because of climate change and also increased globalization, we've now seen them and also beginning to expect that we will have them and have evidence of them in all of the states that you see here. By using this Mosquito Habitat Mapper that I'll explain to you later, you will actually be able to, during active mosquito season, identify the types of mosquito larvae. And I want to emphasize that the larvae cannot hurt you. They have no mouths, they will not bite you. And they're fascinating little creatures. So you'll be able to identify which species you have, which will greatly help scientists and also public health responders be able to know which types of mosquitoes and mosquito larvae have been found in these different regions. So the life cycle of a mosquito is really important to know and actually pretty fascinating in understanding how you can use these different environmental parameters to better understand mosquitoes. So we're going to start off here with the adult mosquito. Now it turns out that the mosquito that bites us, the mosquito that bites us is the female. Whether or not it is a type of mosquito that is capable of transmitting disease, it doesn't matter the species. All of the bites that we get from mosquitoes are from female mosquitoes. The reason they're biting us is because they have eggs, and they need a blood meal to fertilize their eggs. And so they are just looking for someone to bite. They generally bite a couple of people. It can also be animals. But the thing that we find is that if there are no longer animals around, and often people have been moving into, more and more locations that used to be natural areas, and that's one of the reasons in which we're seeing people we're seeing these diseases that are transmitted by mosquitoes kind of becoming more prevalent. So the mosquito, the adult female mosquito, bites us to fertilize her eggs, and then in a couple of days, she is looking then for some still water, some fresh water. She does not look for the salt water, and she also doesn't want to lay those eggs in a river or any moving body of water because then the chances of survival are not as good. So she's looking for maybe an old tire, perhaps. Around my house, my adult children often leave out buckets of water for their dogs, and that is fine to do, and the same with having your bird feeders, as long as you check them every week. But when you go longer than a week, then they can actually go through this life cycle, and you will inadvertently be giving this adult mosquito a wonderful place to lay her eggs and then continue through this life cycle. So we got our adult, she lays her eggs. In a few days, those eggs hatch, depending then on the temperature. That has a lot to do with how quickly the mosquitoes will move through this life cycle. So we have these little larvae, and it is the larvae that we're looking at. They're these little wiggly things that will be in these containers of water. Sometimes you'll also see them in like creek beds. You'll see them in tree holes. They're just these kind of little wiggly things, and at the top they have this, they kind of often will hang from this little thing here called a siphon. And after about a week, it could be 12 days. Again, it kind of depends on the temperature. It could even be faster in some cases where it's really warm. But then they will hatch into a pupa. And they're only in this pupa stage for a couple of days, and then out of this pupa emerges that adult mosquito. And we'll be looking for some vegetation to lie on and rest after hatching, so that's where that vegetation comes in. So kind of cool. Most people didn't realize that mosquitoes actually go through metamorphosis and have a life cycle. This is just a slide showing some of the research that's been done. This was done by someone named Monahan, looking at the potential for Zika to be transmitted in these different regions here. And part of the data sets that Monahan et al. Used were precipitation data, humidity data, and surface temperature data, including some of the NASA Earth observing satellite data. What I wanted to do next was to be able to let everybody take 4 minutes to go to this video. I want you to watch this video because it does a great job of explaining how this NASA data and other data are being used to predict, monitor, and respond to malaria. This takes place in Peru. And as you're watching this, I also want you to be aware of the impact of humans on increasing the mosquito-human interactions based on some of their behaviors. So if we can put the link in here in the chat box. Oh, thank you so much. And then I will stop talking, and I will go ahead and watch the video myself so that I know what time to come back. And mine's finished up. I hope that everybody was able to see that video. I just think, you know, you hear sometimes a picture is worth 1,000 words, and I really like it when we have these short videos that we can throw in, because it not only enables us to have the pictures, but you're also hearing from the actual scientists who are conducting the research. What I thought was you know, really fascinating about that video and the research that's being done there is the way in which they're pulling together these different NASA environmental parameters, and also looking at the impact of deforestation, the impact of traveling back and forth and getting a feel for, you know, where was it that the people were infected. And of course, in this situation, the prime concern, the prime reason for doing this research is to be able to know where to send the resources before malaria occurs. So what I wanted to tell you a little bit about next is is something called the GPM, so Global Precipitation Measurement Disease Initiative. I'm going to tell you about this, and we'll also give you a link, because at this page you are, or at this web page, you will find a lot of different resources which might be useful. This initiative was something that I was put in charge of last year in an effort to bring together research scientists, public health professionals, educators, and the interested public. What we wanted to do was to share cutting-edge research that's being done with this Earth-observing satellite data that related to vector-borne and water-related disease. We continue to work on having a dialogue with potential end users and stakeholders so that they can learn some case studies about what's currently being used, as in the example with benzychek and the malaria in Peru, and then also discuss what are some of the potential challenges for using the NASA Earth Observing Science data for these types of real-world applications. And another really important aspect of this was to collaborate with citizen scientists and hopefully future citizen scientists to share the importance of engaging them to assist in reducing the threat of mosquito-transmitted disease. When you go to the web page, and we'll go ahead and put in the app, I'm sorry, put in that, I was looking here, and I'm awfully sorry that you didn't finish, Matthew. Please feel free to go back and take a look at that. By having access and having the link to that video, it'll be something that is always there for you, and hopefully you'll be able to share with others. So when you go to the GPM Disease Initiative, you are going to see that there's a couple of different tabs. So the first one is About, and in looking at that tab there, you will see if you're interested, you can receive a monthly newsletter, which I pulled together based on some of the submissions that people have given me in what's called our base camp. And I also try to keep abreast of what some of the current happenings are and some of the new resources that are being shared that relate to vector-borne and water-related disease and have an Earth-observing satellite aspect as well. So one thing you could do is you could join the mailing list, and like I say, once a month you'll get this monthly newsletter. You're also welcome to join the collaborative base camp, and there's the link there to do that. For the base camp, basically you just join, and it's something where if people are welcome to submit things, which is what makes it collaborative. If there's latest research, job opportunities, cool resources, just, you know, kind of making it so that it's a water cooler, a place where people can come and share this information. We also have recording of this workshop that we held. We held this beautiful workshop on May 17th. It was an all-day workshop in Washington, D.C., and in that workshop we brought together public health officials, we brought together citizen scientists, and also educators, and we brought together research scientists. So it was a real nice opportunity to hear from all of these different groups, and if you go to workshop, you'll be able to see some of the archived presentations. We also have a couple of trainings up here. If this kind of intrigues you and you think, wow, I'd like to learn a little bit more, we have a beginning level training and then a kind of more of an advanced level training, which focus on showing you how to access these free NASA data sets to be able to look at those parameters that I was talking to you about, like the precipitation and the soil moisture and the vegetation, and how you could take a specific region, like where you are, and be able to find the data for your region. So we have that. We have some research as I find research and make sure that it's research that is already published and people can have access to, then I'll put it up there. It's not only on mosquito-transmitted disease, but it's on any vector-borne and water-related disease, which also is using NASA Earth observing satellite data. I have several videos and media resources, and then finally for resources, you might take a look there if this interests you, because I put up there about 7 case studies, which are done in some PowerPoint slides that show the ways in which these NASA data and other data are being used to better understand, predict, monitor, and respond to vector-borne and water-related disease. And so with that, I will take a breath and I will take a look and see if there are any questions. And I guess if people have, oh good, so enter questions here, thank you. Yes, ticks, absolutely, Catherine. We most certainly, we follow, you know, ticks, snails, actually bats are vectors. There are an awful lot of vectors, but here's something I should throw in here. So NASA is not specifically studying vector-borne and water-related disease. However, what we do is we have this data that is freely available, and kissing bugs as well. And we want to make sure that people who are studying these, who aren't NASA scientists per se, but are scientists that are out there, and you know, and also public health officials, that they know that these data are there and understand how these data are being used. So again, it's not that NASA is studying ticks and kissing bugs and mosquitoes per se, but the NASA data that is being collected and that is freely available to people is hugely useful to enable public health officials and others to be able to monitor when conditions are just right for having these types of vectors. All right, well, tell you what, let me move ahead and I will have another spot for questions as well. All right, so we talked about how NASA is doing this. Now I want to share some ways in which you can be doing this on a regular basis, we hope, and also getting other folks to be doing this as well. So this part I called Engaging Scientists, Teachers, and Students and Citizen Scientists in Using GLOBE. So over here on the left, I have something called the GLOBE program, and you'll notice that this looks like a classroom, and indeed it is. The GLOBE program is primarily a program, and it's been in existence now for over 25 years, but it is a formal education program that is all over the world and involves having students collect data in a specific way, which we call protocols, and then share that data in so that it can be used not only by other schools, but also by scientists. So we've got the GLOBE program, and about a year and a half ago, when citizen science was kind of really emerging as a very, very powerful way of engaging and enlisting the support of people all over the world, the GLOBE program realized that using the smartphone and or iPads, there are so many ways in which we can get citizen scientists to be able to, in a kind of a specified way so that the data is reliable and valid, to collect data. So that is called the GLOBE Observer Program. In both cases here, we have, in this case, students using a microscope, and in this case, my nephew and his buddy, using a little magnifier lens that costs less than $2, actually, sorry, less than about $4 on your smartphone, or you can put it in your iPad. And they're also looking at a mosquito larva to be able to identify it. So what is GLOBE? GLOBE is this international science and education program that's now in 121 countries that allows students and the public worldwide to participate in data collection and the scientific process. It leverages a powerful and growing citizen science network. And one of the big things that we're looking at right now, as we mentioned here, is eradicating Zika and other mosquito-borne diseases. It was announced in 1994, began to be implemented in 1995, and it is implemented through the University Corporation for Atmospheric Research, which is in Boulder. It is sponsored by NASA and also supported by the National Science Foundation, NOAA, and the State Department. I noticed that somebody mentioned they were having some trouble with uploading the app on an Android. We have been experiencing recently some trouble with the Android phones. Please don't be too concerned. They are working on a fix. What you might do if it's not uploading is just stop and then retry. So the cool thing with this Globe Mission Mosquito, which I'll tell you a little bit more about, it's kind of a new campaign that we have, is that it includes both formal education and citizen science efforts. So here we're bringing together the GLOBE program, which is more of that formal education, and GLOBE Observer, which is citizen scientists using smartphone or iPad. Now with GLOBE Observer, you're going to see that there are three what we call tools. You can collect information on clouds. The one that I'm telling you about today is Mosquito Habitat Mapper, and then we have a brand new one called Land Cover. Great. Thank you so much, Ann, for letting us know. That's very, very helpful. Thanks for being a troubleshooter there. So Globe Observer, as I said, is more the citizen science approach. This is open now to anyone. International network as well, working together to learn more about our global network. And this is the one that we're going to be focusing on today, the Mosquito Habitat Mapper. So the goals of the Mosquito Habitat Mapper are to see increased mosquito awareness and decreased mosquito-borne disease risk through scientific data collection and analysis, empowerment, and education. And I'll show you how that is possible. Basically, as I was telling you, we're going to be focusing on this unbelievably fascinating, once you start looking at them, little larva, and it cannot bite you. It cannot transmit disease in any way, shape, or form to you in the larval form. Now, something to be considering, though, is that when you are looking for larvae and when you're using the app, if it is active mosquito season, you, of course, want to take the same precautions that you take anytime you're around active mosquitoes, because where there are larvae, there could be adult mosquitoes out as well. And so you'll want to, wear your long sleeves, perhaps put on your insect spray, that sort of thing. So with this Mosquito Habitat Mapper, there's basically 4 steps. The first step is going to be just finding places where mosquitoes could lay their eggs. So this is something you can be out doing right now. Just walking around, could be inside the house, outside the house, in your neighborhood, just finding standing water and taking pictures of it. And it's geo-referenced. You do have to have your settings on. It will automatically have your date and your time. It will automatically have your coordinates as long as your settings are on for location. And that step in and of itself, being able to know where there are potential mosquito habitats, is important data. Sometimes that's all you will do. If you could also eliminate, pour out the water, then you've got 2 steps done. So both of these steps, 1 and 4, can be done when it's not active mosquito season. Then there's another step, sample and count, and then the 3rd step is called identify, and I'll show you how each of these steps work. So basically, you'll use the Globe Mosquito Habitat Mapper to determine if you found a potentially dangerous mosquito, and again, by looking at the larva, or one of the approximately 3,500 other non-disease carrying species. And I just have here an acknowledgement that slides 20 through 24 were made by the science lead for the Globe Mission Mosquito, Rusty Lowe. It really is as easy as can be, and that's something I want to stress. You do, as many of you have seen, you get this one-time password. The only time you have to use it is the first time that you're doing this, and internet is not required for data collection. In this case, this is my sister, and she's looking inside this pretty hanging thing that she has out in her yard, realizing that water collected in there. So she's just taking a picture of a potential mosquito habitat, and then she submitted her data. Here was a school that I was visiting, and these were some, after it had rained, this is a pond that generally has water in it, and so that would be a habitat that I could take a picture of, but I couldn't eliminate it, but certainly having the picture and knowing it's a potential habitat is important. And here are some smaller containers of water. Each of these would be separate pictures. I'd take a picture of this, and then I'd also take pictures of these. And of course, in this case, I could eliminate that potential mosquito habitat. Over here, I have some students that are using an iPad, and they have one of these lenses, and they're magnifying the larva and trying to identify what kind of larva they have. So when you get started, you're going to see that you've got a couple tools. You've got cloud, mosquito habitat, and then there's that third one, land cover. When you get a chance, go out and play with these. You can't break them, and they have all the directions embedded inside each of these tools. And should you have any questions, it's easy enough to just go to questions and ask your questions. They're really good about getting back to you. So you're going to start with your first couple screens. It's going to give you some information. I'm going to give you some cautions here about making sure that you are using the proper protection that you need. When you are doing your observations, you're always going to start with a new observation here. Now, if you're somewhere and you didn't have internet connectivity, later when you have internet connectivity, that's when you can review and send your observations. Here you can see your data, and here you can see the data from all over the world where people have been submitting their measurements. And then you move on, and like I say, there's just 4 easy steps. Identify your habitats, count, sample and count, identify your larva, and eliminate your breeding sites. And yes, to everyone, you can skip the referral code. That's just if we're working on training a specific group of people and we want to collect metrics to know which of the people who were trained are using the app. In that case, we would use a referral code. Good question. All right, so step 1, observe. Just go out there, take pictures. Now, this is kind of fun. Anywhere that there's standing water is where, you know, your mosquitoes might breed, and these can be inside or outside your home, a little disturbing, I know. And it works kind of like a choose-your-own-adventure. So you look over here, what is the source of the water? Sometimes you're going to have something where you're not exactly sure, you know, oh, is this artificial? Is this, you know, natural? You know, which of these does this fall under? You're not going to ruin anyone's doctoral dissertation if you do not, you know, answer this with 100% accuracy. So not to worry whatsoever. I'm going to take a question. Are observation numbers all observers or yours only? So when you're looking at your data, it's yours only. And when you're looking at today's observations, it's everyone's, everyone who submitted the data. So you're going to start off over here. What is your source of the water? In this case, I'm going to say it's artificial. It's like, I'll say in this case, it is a piece of, I'll say it's a piece of trash that somebody left, a cup or a water bottle that has collected some water. So now, okay, what type of artificial container? I can say, is it discarded item or trash? Then discarded item. It even gives me more choices over here. So each time you're kind of clicking further and further in there, and then you take a picture, and then you're done. So get out there and practice with that. Take your pictures and send them in. That is really important information because it helps to start to identify where these potential breeding sites are. So let's say it's active season. You see there's some of those little wiggly things in there. What you can then do is use a cup, a bulb syringe, or another container to obtain a sample and count the number of larvae. And all of these directions are right there in this app. If you don't see any larvae, you just say no and you move on. You can also say if you think you see mosquito eggs, pupa, adult mosquitoes, and you'll get this nice little congratulations, even if you have just taken the pictures to identify potential breeding habitats. If you can eliminate them, dump them out, that's another step. So this is the step that's the hardest, but it's also pretty interesting and fun. This tells you all the things that you need. Excellent question, but I'll tell you basically what you need is a cup. And when mosquitoes are active, you want to have some sort of, I put on bug spray, you know, mosquito spray. The other thing that is really useful to have to identify the mosquito larva is it's called a cell phone magnifier. We're not allowed to tell you what kind to get because we're not allowed to try to endorse products. But I will say if you just look on Amazon and you put in cell phone magnifier, and in this case you just need it to be able to magnify 60 times or more, you should be able to find some. The most expensive I've seen them for is $7.99, and the least expensive has been around $4. And once you do this, it also, inside the app, it will go through and give you these directions. When you pour out, and if you have a little pipette or an eyedropper, that's also helpful. If not, you just use your cup, you pour your little larva onto some kind of a white surface, then use a paper towel or an eyedropper to soak up some of that extra water, because these guys are going to be so active, they're going to be so wiggly, they're going to be hard to see. Another thing you might do once you are ready to start doing, and here's that little magnifier I was telling you about. When you're ready to start observing them, you might also put in there just a little drop of like an alcohol solution. It could be the stuff that you use on your hands to you know, wipe off bacteria, because what that will do is that will go ahead and kill them, and then they'll be still, and they're easier to try to identify when they're still. Otherwise, they're pretty busy. So the three main types of mosquitoes that we're going to focus on attempting to identify are three of the species which are most likely to transmit disease, and those are Aedes aegypti, Aedes anopheles. Both of those are able to transmit Zika. And then finally, the Culex mosquito. And you'll find information on those in that app. And also, I think maybe we did put up, but there are a couple of different websites you can go to. One is the Globe Observer website, where you'll find lots of resources and lots of PowerPoints and other things as well for how to use and how to teach others to be able to use this tool, the Mosquito Habitat Mapper, as well as land cover. Thank you so much, Sarah. Land cover and also the Clouds app. So lots and lots of resources there, and you'll be able to find more information on each of these different types of mosquitoes. As you get into this, especially when, you know, during active mosquito season, it gets pretty interesting to go and find these larvae and get a feel for, well, you know, are their eggs in rafts, or are they kind of more single? How do they use the siphon? How are they hanging in the water? What do their larvae look like? And then hopefully you're not going to be too close to the adult mosquitoes, because we're not attempting to identify the species of adult mosquitoes with this app, just the larvae. And then the last step, eliminate. Remember, that's the most important thing that we can do to reduce the transmission of mosquito-borne disease, are to eliminate, when we can, these bodies of water. So then I also want to invite all of you to become a part of the Globe Mission Mosquito Campaign. This is what I'm the education lead for. In this campaign, what we're doing is we're bringing together our scientist, Dr. Rusty Lowe, who is a very renowned scientist in the field of understanding mosquitoes and mosquito-transmitted disease. We are also bringing together teachers and students and scientists, and in addition to that, we're bringing together citizen scientists. What we're doing with these different groups is we have three large science questions that we're going to work on answering. We have a team of scientists also who will be using the data that we collect to be working on answering these questions, and will be reporting back to us what they find. So we want to identify the baseline for the range and distribution of the Aedes aegypti, Aedes albopictus, and the Culex mosquito. We want to identify the seasonality of those, of local mosquito vectors. We want to know from all of you, what was your first sighting of these mosquitoes? What was the last sighting? What is the period of the greatest number of observations? We're also hoping to quantify change in mosquito frequency and distribution at the local, regional, national, and global scales, and understand how those environmental parameters like precipitation, land cover, surface temperature, moisture, and vegetation, how all of those seem to come into play. And I will get to your questions in one sec. I'm going to just finish this part here, and then I'll take a look there. So with our formal education, we have K-12 webinars and a newsletter. We are assisting students and teachers with science fair projects, helping to share best practices and ideas for collaboration, showing them how they can use some of the GLOBE protocols, which do things like look at air temperature and precipitation and soil moisture, in addition to the Mosquito Habitat Mapper, and then offering mentoring support. For our citizen scientists, we also are going to start monthly webinars in January and have a newsletter. You'll have direct access to scientists. There are partner projects where scientists are interested in the citizen science data to support their research, and then lots and lots of ideas for libraries, nature centers, museums, etc. Here are some of those useful resources, and now I will take a look here, and or actually, Sarah, perhaps you could catch me up on any, oh, I'm sorry, I see, okay, so I want to take questions now, and I see from Kim, if you can't empty or drain the water, other recommendations. So Kim, there's a couple of different things. I'm thinking that if it is your own personal water, there are, you want to take a look at, I would just do a Google search, mosquitoes, put in where I live, Montgomery County, mosquito prevention, and see who in my county is responsible for mosquito prevention. Get in touch with them and find out what they're finding is most effective for the standing water. If I was working in a library or with a, with a group of school children, I would also have them do this search, find out who's responsible for the mosquito control in their area, and then ask them, are you aware of this, this, and this, and have those pictures there, that data ready to show them, and then ask them, would they, what would they make sure that they're taking the appropriate precautions, which is generally putting in some sort of, either putting a spray or some sort of a what's called dunk into that body of water to ensure that you're not going to have mosquitoes breeding there. So let me see, are there any other questions that anybody might have for me?
Hi, Dorian. I just wanted to let you know that I think you've answered all the ones that have come in so far. We'll see if anyone has any additional questions here at the end.
Fabulous. Thank you so much. Having been a classroom teacher for so many years, it is still a little challenging to do a webinar. While it's nice, because unlike when I taught middle school and had to worry about things like spitballs flying, on the other hand, I can't see your faces. I can't rely on body language and some of those visual cues to know how this is being, if this is being understood. So thank you.
All right, well, it looks like, well, that quick question is for me. This is being recorded. The link for the recording can be found on our website in our archived webinars page. I'll pull that link up in just a second, and we will send it out in an email with an announcement about our next session as well.
And please feel free, anybody, get in touch with me. Should there be any questions that you had that I didn't answer, or just something that intrigues you, that tastes like more, you want to learn more about, please go to the GPM Disease Initiative and sign up for our monthly newsletter. Just kind of keep abreast of what's going on. If you'd like to be involved in the kind of that more collaborative effort, jump into the base camp. You don't even have to be a collaborator. You can just kind of sit back and get a feel for some of the different things that are available on the base camp. And both of those links to join and get the newsletter or to join the base camp are right there at the Disease Initiative. Globe Observer, make sure you jump on there and take a look at what we have. And then Globe Mission Mosquito, we'd love it also if you signed up for our newsletter and thought about joining our webinars, when you're available to them, and just keep up with what we're doing. Yeah, there really is, this is just fascinating, and the fact that we have to be more concerned about mosquito-transmitted disease even here in the United States is a really important message. We don't want to scare people, but we do want to make them aware and also have them feel empowered, because the concern of these mosquito-transmitted diseases is something that with our changing climate and with our increased globalization, is something that we are very concerned about, but we also know that by empowering people to know what, you know, to dump the water and to be vigilant, that has every, you know, every possibility of not making this something to be scared of, but rather having it be important information. And if any of you happen to be in the Washington, D.C. area, there is, for the next 3 years, it opened up in May of 2018, there is this wonderful outbreak exhibit, which I'm very happy to be a docent for, that focuses not just on mosquito-transmitted disease, but on the outbreaks of a lot of different diseases that are, and diseases that are caused by viruses, which is just really, really fascinating information. Great, yeah, please get out there, use the app, and again, if you have questions, there is lots of help available through the Globe Observer website. They really respond. Go ahead and order your magnifying attachments so that when you do have active season, you can use them. Plus, they're just super cool to just keep in your pocket or your purse and, you know, take out and take a look at how beautiful a leaf is or a cool beetle that you find. So you all are very welcome. Thank you for attending. My pleasure. And
thank you so much, Dorian. I will ask if everyone would stick around for just a few more minutes to let me run my reporting poll. Thank you again, Dorian. This was a really fabulous presentation. We really appreciated you being here with us today.
Thank you. You ran it so well. You made it easy, so thank you so much.
All right, I'm going to go ahead and stop the recording now.